Hello, hello, dear teachers. Hello, dear colleagues. My name is Leonid. I am professor in Lappeenranta-Lahti University of Technology of Finland, and I don't know how, but I am so privileged to give a chance to talk to you. Of course, I wish I were with you physically. It would go much easier. Or at least I wish it were like a online translation of what I teach, because again it would have a feeling of like of being together at the same time. But unfortunately, like for the sake of safety, we decided to record this lecture. So I will try my best to keep you engaged for maybe 20, 25, maximum 30 minutes to sharing what I have to share with you. Well, like as soon as I was invited, and thank you very much for invitation to present something in front of JET meeting. I felt like it's like a call because there is something that I definitely need to share about creativity and how to teach creativity. So give me a second. I will share the screen and we'll go through my PowerPoint slides that hopefully uh, can help to illustrate what I am going to say. Okay, this is my beautiful presentation, and I hope you are actually seeing it. And then, that is officially open. Good. So we are talking about creativity because if it is an elevator speech for creativity, I think that is what we are missing. That what United Nations and so many organizations and just conventional wisdom puts as one of the top three skills of modern kind, modern life, let's say, of let's say modern labor market or whatever. And that is what is interestingly enough, it's everyone likes creativity, but all teachers understand that it is a bit kind of difficult to teach because it looks like a blessing, kind of a gift, but not a skill that you can pick up the same way you pick up a multiplication table skill or the skill of playing piano or something like this. So why I am just brave enough to tell you something about creativity? Because my life is a kind of zebra, and there is a stripe. One part of my life I spent in industry, and some part of my life I spent in academia. Most of time I was professor for academia, but I was not ivory tower professor. I actually worked for companies like Samsung Electronics or LG Electronics, or a consultant for a big company. And my main job was to create, to let's say, to design, to invent something on demand. And that is why I anxiously think that I just know what I'm talking about. Yeah. So again, in short, you can already maybe switch off translation after this slide. But what I want to share to you, what I want what kind of ideas I want to share you. Three. That first one is the most important. Creativity can be taught. So it is not a blessing. It's not a gift. It can be developed the same way like any skill. Second thing, there are some tools for creative thinking. There are some systematic tools, theories, methodologies, how to think out of box, how systematically produce new ideas. And I strongly recommend one of which that I used a lot through my career, that I'm still teaching, that I'm researching, publishing. It's called the Theory for Inventive Problem Solving, or TRIZ abbreviation. So, and the last one, I will speculate, lamely speculate on how we can design a class that is engaging, that is problem oriented, or let's say PBL, problem based learning, and then creativity sits inside. Okay. Good. If you agree, let's go further. And yeah, I actually prepared so many slides. I will try to go really fast, but because this is a record, you will always can put on hold something maybe later, and maybe you will fish out something useful for you. Well, first of all, I want to show you some examples that pretty much impressed me. Do you know what is this bottle in the roof about? It's actually amazing lighting tool. Yeah. So you see, it looks like inside of the shelter, it looks like a electric bulb, but it's not. So because of a little bit of physics, because of refraction that happens in this empty bottle when it is filled with water, so you can get a little bit more light than just a hole. But it is literally lighting up faces, cuts electric bills, and makes like a little really easy. Yeah. It's the same time it's so simple. So it's an invention that changed the lives of millions, while it costs, I don't know, but it's actually like have a negative cost because you are using you are getting rid of waste, so of empty bottle. Very nice. Maybe you came across a solution that became a kind of viral, maybe 10 years, maybe 15 years ago. But I want to say it's not just a beautiful idea of or just a nice video for Instagram, but it's also a business. So a company that is still alive, you can check a website. It's called Liter of Life, and still providing affordable, cheap solutions for lighting. And another example, there are still a lot of areas in which the access to fresh water is not so good. So you have to travel long distances with a canister of water on top of you, and it's not the nicest experience, especially if it is like long distance. So somebody became like a kind of conserved. This is a problem, and we have to address this problem, and came up with a solution that I don't know, as an engineer with experience, I would say it's a brilliant, it's a genius because you see, you just change the shape of the canister, and then you add the handles, and altogether would be, I don't know, maybe I don't know, one bucks maximum. But now you can do it easily. Even a teenager can do it. So it happens like itself, it rolls itself, and on the top of everything, maybe the quality of road is better. And I want to emphasize it's not just a haha or a nice solution, good job, but it's also a business. And you see the link to another company that is called Hippo Roller. That is very nice name, and the company is still trying to spread the cheap, affordable solution that make access to water better. Okay, and another example, and I give you a couple of more examples, and we are done. Look, this the guy's job is to sort fruits. So, like small fruits go to one box, and bigger fruits go to another box. And okay, if you are like a modern engineer and with a lot of knowledge about how to do automation, you can create a robot, or you can create, I don't know, artificial intelligence based image recognition, and the robot will sort them and find. But we don't have money for it. We don't have resources. So, and then the guy did a beautiful job. Look how he arranged it. He put two bars at the gravity that is always here, and it sorts itself. And itselfness is very good word. Very good word you will learn. Okay. Nice. Hopefully you enjoy it. You are possibly like, smiling the same like I smile. Yeah. And the one more solution, just to give you complete idea of what I'm talking about. Yeah. A gate, self-opening gate. So typically when we think of self-opening gate, we always imagine something complicated with a proximity sensor, with a drive, electricity, and so on. But look how beautiful the solution it is. So it works really ideally, yeah, in a way that it works when it is necessary and where it is necessary. So that means that as soon as we have the car to let it go, so then we have a solution that is coming. Okay, and let me go a bit back with this. Please let me back. Oh my God, looks like we are stuck with this. So let me for a second share. Yeah, stop sharing and start sharing again. Technology. But please, I need your concentration on the ideas that I try to show. Yeah, now I got rid of it. Yeah, so all of these solutions that I'm trying to share with you, they have somehow something in common. And okay, now I'm back, and let me share. Yes, and one more here, and then hopefully I'm sharing, and this is my presentation. Yeah, hope you can see it now. So they have something in common. They are not rocket science. They are easy. They are affordable. They are pretty cheap, and at the same time they're very influential. So, and I would put it all together to trying to inspire you in this inspirational introduction that creativity really helps to solve problems of community, of family, of I don't know, municipality. And creativity helps to solve it with a kind of minimal resources. So you don't have to be rich to solve the problem. So this is to inspire. So creativity is a good stuff, but the next natural question comes, how to make to let's say to be creative on demand. So the message I'm trying to share with you that creativity can be taught. There are certain instruments of creativity, and okay, I don't have I don't have time to let's say to give you all the instruments and to explain of them, but I try to in a way to infect you. I don't know if it is a good word after COVID, but to infect you with the knowledge that creativity can be taught. So, and again, one of the instruments of one of the strongest instruments I was exposed through my professional career was theory of innovative problem solving, of which I will show just two tools. One tool is called ideal final result, and another is called contradiction analysis. So let's go. Ideal final result. So the Genrich Altschuler, who was the father of trees, he somehow postulated what does it mean to design a good system. So what good system means, what ideal system means, and he liked a lot of like paradoxes, like contradictions, and his statement was a kind of paradox. So ideal system is no system, but the function is ensured. So no system means no cost, no operation cost, but the function is to be ensured. So it looks like a magic, like you just what a stupid idea to try to think you can get something from nothing. At the same time, this paradox works. And if we go again from this, look, so there was a very difficult problem how we have to carry a canister of, to design a cart to carry a canister of water. At the same time, a small change in the shape could somehow, let's say, definitely help us to came up with ideas that like ideally the canister rolls itself, canister carries itself, and this itselfness is the ideal final result. Or look at the sorting mechanism. Yeah, ideally it sorts itself, so it's very, I mean, you don't need laser schmazer or optical, I don't know, any device or something. You don't need robot, but it still works. Yeah, okay, no, I don't want to. Yeah, ideally it opens itself. So if we go through all these solutions that possibly you admire the same way I admired them, then you can realize, yeah, looks like in all these solutions, the desired action, the desired function has been reached itself. So we change the design in such a way that what we need happens itself. Yeah, and now I can try to give you a couple of examples from more serious, because you can think, oh, that is only just cheap, frugal innovation, so it does not work for serious things. No, it works. I would like you to just to pay a little bit of attention. Maybe I need again to concentration. There is a two launching pads for rockets. One is American, and one it was designed in Soviet Union. So there's the same idea. You have to hold the rocket before it starts, until it starts. When it starts, you have to release it. So there are masts, two masts or more masts, and they hold it. And well, at the moment when the rocket starts leaving Mother Earth, you have to open it. If you open it too early, maybe it could fall down. If you open it too late, you can damage the shell of the rocket or something. So in America, they designed a pretty expensive hydraulic electrical mechanism with some drives that, you push bottom, it opens up. And in Soviet Union, possibly because we were a little bit like, always short of resources, that was a beautiful design that actually the rocket was holding itself. Yeah. Can you see? Can you recognize that there is a counterweight? Then when you install a rocket, it like locks itself. But as soon as a rocket starts losing the weight, yeah, because it flies, it's about to fly, then it starts opening up. So it's a beautiful, elegant solution. And why it is so beautiful? Because actually, when the rocket starts, everything is burned. So in America, they have to to rebuild each time. They send they send a rocket to the sky, they have to rebuild it because everything is burned because of plasma that's coming out of the rocket. While in the Soviet Union or maybe now in Russia, then it is they're like it's very simple design in which you don't need to replace so many things. Yeah, and this is actual photo and the patent of Russian Federation. And what you see on a screen, this white things, it's just a concrete, a piece of stone. So this is automation that doesn't require any controllers, any sensors, and it works. And so even a schoolboy or schoolgirl can understand it. And one example from my practice, when I worked for LG Electronics or for Samsung Electronics, I work with so many home appliances and semiconductors and other developed, technologies. And refrigerator was one of my favorite. I have some patents on refrigerator too. So what you see here is an ice generator. So inside of any most of advanced refrigerators there is an ice generator, and maybe 20 years ago there was like a manual system like on the left on the slide. So it was a plastic tray, you fill it with water, you wait a certain amount of time until it is frozen, and then you manually turn it upside down and twist a little bit, and then the ice cubes fall down because of gravity in the ice bank. Yeah, okay, but people are getting more and more lazy, or as they say in America, they are getting more and more busy. So they have no time for it. You want push bottom solution, and they designed the push bottom solutions that you see on the slides is like a Frankenstein. Why it is Frankenstein? Because it's an aluminum tray, and there is a freon going around it, and it's becoming like minus, I don't know, minus 40 Celsius. And then the ice appears, the water is frozen, but then you have to get rid ice out of it. And it's very difficult because ice is frozen in. So they designed a heater. Imagine inside of the freezer there is a heater, and heater heats up a little bit the tray, like maybe I don't know during 1 minute, couple of minutes. Then ice melts up a little bit, and then a special yeah, you can see it's a blade. Special blade makes one turn and gets the ice out of the tray, and it falls down again. So it's a monster, definitely pretty complicated system, because unfortunately it's a kind of tradition of in engineering to create things by adding. So we need cooling. Okay, let's add the cooler. So now we need heater. Okay, let's add heater. We need now cold air. So let's add ventilator. So we are always adding, 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 and we end up in Frankenstein. And this is a beautiful solution. It's so beautiful. I really admire. I can look at this slide during like moments. Yeah, this is a patent of General Electric in which the beautiful and simple design is suggested. So look, they suggest to use a kind of symmetric tray, and you add water to the tray, so it is frozen. You turn it upside down and you add more water. So, and because water coming with the room temperature, so it's warm, so it melts up the ice and falls down. At the same time, ice loses some frost to the water that is to become ice very soon. So it's a very elegant system with what is called in science recuperation of energy. Super nice, simple, and again, this is ideal final result. Ideally, everything happens itself. So that was one tools all in one. Before to design something new, think about ideal final result. So ideally, it happens itself, and then it helps you to say to activate resources, hidden resources you never notice, because when you are short of resources, or when we are poor, so we are very inventive. Tool number two, it's called contradiction analysis. What an animal it is. So it is nowadays not easy to be inventive because we learn to optimize, we learn to be tolerant, we learn to rather to optimize, let's say, to find some balance between two maybe contradicting demands. So the message from Mr. Altshuler was that, yeah, instead of compromise, try to find a solution that would lead to win-win situation, to win-win solutions. Yeah, and every problem, Mr. Ashuler said, becomes inventive problem if you resolve or eliminate contradictions. Several examples, and I'm done with the theory. So one example I like a lot because it comes from the history, maybe third century, before Christ, and there was a dynasty of Ptolemy, and in Africa, in northern Africa, in Alexandria, they built a huge, colossal building, and the engineer was Sostratus. Who actually was a designer of the project, supervisor of the project. So he's very proud of it, and he wanted his name to be on carved on a building, while his boss, Ptolemy, who was a king, wanted eventually his name to be carved. So it was a contradiction, definitely contradiction. And possibly you can imagine a kind of contradictions you can have with your boss or you with the principals. It's always a kind of dangerous, yeah, not to try to find, not to find the find, not to try to please your boss. So then Sostratus had a kind of option. Okay, you can try to compromise. You can say, okay, maybe I will have a Sostratus in big letters, or sorry, Sostratus in small letters, or Ptolemy in big, or maybe one side would be Ptolemy and another for Sostratus, but all of them, all the solutions would be a kind of compromise, right? So Sostratus came up with a beautiful idea. So he decided to carve his name on the top of this beautiful, colossal lighthouse. And he wrote, carved in stone, built by Sostratus for people. And then he put clay, atop of it. And then on the clay, he wrote, built by Ptolemy. So when Ptolemy came to enjoy the building, he said, yeah, good job, because it was his name. But after maybe 50 years, the clay flaked off, and everyone saw that it was built by Sostratus for the people. But at the time, Ptolemy was dead, and eventually Sostratus was dead. But the message that Sostratus wanted to send was sent. And this is example of contradiction elimination. It's not a compromise at all. It's a kind of win-win. Ptolemy is happy because to see his name perishing his ego, and Sostratus was happy because actually the generations to come knew that Sostratus was a designer. Okay, a couple of other examples. Yeah, and a needle eye is typically a contradiction. Could be seen as a contradiction because to get a thread through the needle, you have eye to be big, but let's say to when you start stitching, you want them to be small, and typically it's optimized, right? So you can get a needle from the market in a shop, from a shop, hardware shop maybe, and it will be always a kind of optimized, neither big nor small. So that was a very nice and very successful patent of the British designer. His name was Pace, and he actually designed something that is could hardly be called a needle, but the same, it was a needle. There were two wires of stainless steel, very hard steel, and he suggested to weld them together and sharpen one end so it's become like a needle. But if you press against each other a little bit, it becomes one big eye, as you see in the figure 3. So it's a very nice idea, and as it should be in any successful creativity application case, it became a patent, and the patent is the first step to do successful business. Yeah. So in this way, we use different techniques of separation. We call it. We can resolve contradictions by separations. So no more lecturing. It was a lame attempt to try to explain you that whenever we need systematic idea, whenever we need out-of-box ideas, there are certain tools about it. And I just shared with you two ideal final result concept and contradiction concept that maybe you will possibly learn yourself or together with your classes later. So, and all together, it is packaged in the theory of inventive problem solving, and I leave you this name with, and you will definitely find a lot of literature in internet in so many languages. Yeah, if you find nothing, you can type in YouTube Chechurin, and this is my family name, and you can find my open lectures on creativity. So, as the last thing, my lame speculations on how the class should be designed to be creative. So, There are some popular words in modern education. I listed them. Yeah, you see this problem-based learning or project-based learning, student-centered engagement, STEM. I'm a big fan of STEM. This is a science, technology, engineering, and mathematics because I believe it is a foundation of, if you want, economy or prosperity, and so on and so on. So what if you put all of things together, how the class could be designed? I suggest what I am doing at university in my course of creativity, and I try to reduce it to what you can do in a class. So I suggest three steps. First, you introduce a problem, then you generate ideas on, let's say, with certain tools, and third, you do assessment. The first step is very challenging at the same time because I mean, what I want to say, it's easy to solve problems, really, but it's hard to find proper problems. And the problems you have to see, and you can see that this is a problem, and you have a kind of curiosity and to be adventurous enough to try to solve it. So the problem could be unsorted waste in a trash bin. As the problem was a leak of water from the tap. The problem could be a challenged friend for whom maybe to do something that you can do easily is a challenge. Yeah, the problem could be design of the boring school bags that you want to do it different. The problem could be carrying long distances a heavy canister with water. The problem could be some insects that are fighting our fruits or our vegetables and so on, so on. These problems should be found together with students, and this problem makes students interested because they were his or her choice of problem. And what I do, you can see on the right, I make an announcement, and because at university we try to solve a little bit more serious problems. So I'm looking for customers, for companies that need creative solution. Maybe you can do the same. Yeah. So this is a situation. This is what everyone see. But to formulate this a problem, maybe that's also really inventive step. Look, so this could be the problems. Let me pick up just one and see how we can go through it. For example, dangerous mouse trap. So the problem is that we want to get rid, for example, of mouses, but traditional mouse trap is a kind of inhuman because it kills the mouse, first thing. And second thing, if you have pets at home, it could damage your cat, it could damage your dog, it damages your own feet when you go at night to the restroom and so on. So you don't like it. So you have to change the design. What are indications that the choice of design problem is good? The problem is to be exciting, it has to be valuable, it has to require design, so it shouldn't be abstract problem. And ideally, the problem is specific. Don't try to save the world. Try to help your school. Try to help your community. Try to help your city. So it has to be very specific. And I put some textual things, if for your reading pleasure, then you can enjoy a bit later. So example, let's face a design problem. A standard spring mouse trap is effective, but unfortunately they can kill the animal and can be dangerous. Oh, and we are not happy with it. So we raise the problem how to improve the situation. If you apply ideal final results, ideally there is no trap. But when the mouse comes, it cannot go away, ideally. So this is a kind of how to say it, almost science fiction situation. So we have to imagine it, but then we have to make it realistic. Is there any solution that could make mouse be a kind of stain against its will? And one of solution is already in the market. So there is like a very sticky surface then like the holds mouse. So once the mouse enters, so it cannot escape. And believe me or not, it's already can be found in the market. And this mouse trap is ideal because there is no spring, there is no killing, like ramp for the mouse. Yeah, or we can formulate contradiction. I want the mouse trap to be open because the mouse is to enter. But I want it to be closed because once the mouse enter, I don't want it to go out. So this is a contradiction that should be resolved in time. When I want it to be open, when the mouse is out. When I want it to be closed, when the mouse is in. And of course, this separation principle could add up in several solutions. You can really find some of them on YouTube, some of them are sold. So you see the different constructions, but they do the same. Once it's open, but once mouse enters the device, the door is closed and the mouse cannot leave it. Okay, beautiful, nice. But again, you don't need to be a PhD to design them. And the final thing, as a teachers, we have to carefully evaluate the idea, what we have to understand, what we have to check, how students communicate the idea. So make them make a drawing, make them make a clear explanation, preferably textual explanation, make them doing presentation. So how understandable is the idea for you or for the rest of the class? Is there any text? Is it textually written? What is going to be? What is the idea about? Are there any drawings? Is there any proof of principles that it work? If let's say like secondary school or high school, it should be rooted in physics, in basics of physics at least. Yeah, and what is very important, we have to celebrate ideas and we have to celebrate the authors of ideas. So please check that there is an author and there is a date, because that would teach the students the culture of communicating the idea and potentially protecting their own intellectual property. Yeah. And then checking how realistic is the idea. You have to evaluate, does it contradict physics or not? And then if it doesn't contradict physics, can we manufacture it? Can we manufacture it in hundreds of copies? Because definitely we are interested to make business out of it. Is it productive idea? Efficiency is high. Is it sustainable in a way? Is it environmentally sustainable? Is it economically sustainable? So is it going to live after funding is over and so on. So what is the approximately cost of it? So for higher school, it could be very nice exercise of entrepreneurship. Yeah. And finally, we have to evaluate if there is a market for this mousetrap, to whom we can sell it. Yeah, for example. So all together. Whew. So I'm coming to, to the end. It's almost midnight here in Finland. And again, three messages I want to share with you. Thank you for doing it with me through the whole lecture. First, creativity can be taught and creativity should be taught. So it's not a gift, it's not a blessing. So it could be taught the same way we teach mathematics, physics, music. So it can be a separate subject in your curricular, or it could be an element of almost any subject of your existing curricula. Trust me. So, second thing I wanted to share with you, that there are tools for creativity to support creativity. There are theories and methodologies, of which I strongly recommend the theory of inventive problem solving. Google it, ChatGPT it, Wikipedia it. So when there is a wish, there is a way to get information on it. Or if you fail with everything, contact me, please. And finally, let's say, uh, there is a strong trend in modern school to make it more successful. So we are not teaching subjects, we are not teaching skills, we are teaching problem solving. So problem-based teaching, project-based teaching, student-centered teaching is a key. So, and I tried, my best to help you with the design of the class that I'm practicing at higher school, but definitely it could be adapted in your class, in your school, in which we put in the center of class a problem, a real problem of, as I say, community, of school, of family, that solving of which is a kind of would make the life easier, could improve the life. So, and then we try to solve it with all the tools we have, and here creativity could help. So that would definitely make our classes much more than classes. They will teach our students to solve problems and make them more maybe confident in future life. Great. Thank you very much for your attention. And yeah, you can always contact me through Facebook, LinkedIn, and other tools. So good luck in school.